All right, we're on our 6th day of factoring, so hopefully you're starting to get the hang of it. Today we're going to talk about factoring mentally as opposed to using the box. Now what we've been doing, if we go on and move this up a little bit, what we've been doing is using the box here to factor a problem like this, even if there was a number or coefficient in front. It's much more difficult to factor with a coefficient in front of your quadratic equation. So, using the box, what we found was that if you have something like this, you put your x term here, your x squared term here, and your number here. And we have to figure out what goes in these other two boxes. And remember, the story was that it had to add to be negative 7x, and it had to multiply, let's add and multiply, to be 12x squared. I'm trying to do this with a mouse and it's not working very well. Okay, 12x squared. All right, so factors of 12. This indicate this one, that positive sign right there, indicates that the signs are the same. They're either both positive, I said positive, or they're both negative. The one they're both positive or both negative. Then we look here, and that tells me that they're both negative. Okay? So, we're going to figure out again factors that will multiply to be 12 and add to be 7, and that's going to be negative 3x and negative 4x. Okay, so we're going to put those in our box, and negative 4x. Okay. Now, again, we're finding area on the outside, finding the dimensions that will give us this area. So the length and width that give us x squared are x times x. On this box, the length, this dimension's x, so if we multiply that by negative 3 here, we have an area of negative 3x. This dimension is x, so if we multiply it by negative 4, we have negative 4 times x is negative 4x, and negative 4 times 3 is negative 12. So our factors are x minus 3 and x minus 4. Okay? Now, we can do a lot just mentally using our brain capacity that we have. When there's no number in front of the x squared, I don't recommend you try factoring mentally unless there's just no number right here, unless that's just a 1. Because let's see what we can know. We can know, okay, the first term is x in both of our sets of parentheses. That's the only way to get x squared. Okay, so we're going to put x. Again, this sign, the second sign, tells me whether they're both positive, both negative, or one of each. Well, to have a negative, the only way you can do that is to have a plus and a minus. And we want things that will multiply to be 30 and add to be negative 6. And the only way to do that would be 6 times 5. And we know to be negative 1, we're going to have negative 6 and 5. And when we multiply this back, we get this equation. Remember, always check it. Multiply it back and make sure you can get your original equation. All right, here we have m squared, so we're going to put m, and we're going to put m. And we have a plus sign here. Signs are the same. Look here. That means they are both negative. So we have two negatives. Factors each have a negative. I wish I could get my Mobi to work, but I can't right now. So I'm doing it with a mouse. Okay, so m minus. All right, so factors that add to be 20, or multiply to be 20, add to be 9. That would be 4 times 5. Okay. Now, we've got b squared. So we have b times b gives me b squared. Their both signs are both positive, so that means the signs in both the factors are going to be positive. Multiply to be 14, add to be 9. That would be 7 times 2 and 7 plus 2. So we just put those in there. So again, with that, with no number in front, no coefficient in front of the squared term, it's pretty easy to factor quadratics. We have a and a. Since our second sign is negative, that means one of the factors is plus, one is minus. Add to be 24, or multiply to be 24, add to be 5. It's going to end up being positive, so we have a positive 8 and a negative 3. Okay? Then we have 8 plus a, okay, we have p. So we're going to have a p squared. P is p times p. Positive here, negative here means both the signs are the same and they're both negative. So we put p minus in both of them. And multiply to be 18, add to be 9. That would be 6 times 3 is 18. 6 plus 3, or negative 6 plus negative 3 is 9. And let's see if I can't write that one a little better so it's legible at some level. Okay, there's my 3. All right, now looking at this, we have a coefficient in front. This is not a trinomial. This is a binomial. Minus sign between, red alert, it could be a difference of squares. So then you look at the each element and find out, yes, I can take the square root of 4x squared, and yes, I can take the square root of 49. So it must be a difference of squares. So my answer is going to be 2x minus 7 and 2x plus 7. Okay. All right, now 8 you can't see very well, but it's 2k squared minus 5k minus 12. We have a coefficient in front of the x squared term at this stage of the game, so we're going to go ahead and do the box. Okay. And we're going to put in this first part 2k squared. And down here is negative 12. We have to figure out what goes in the other diagonal. We need it to multiply to be negative 5 and add to be negative 24k squared. One of each. We've got a positive and a negative. Okay, and I didn't write all that out, so but if you need to, write it on the side. Remember, adds to be negative 5, multiplies to be negative 24k squared. One of each, one positive, one negative. So that would be negative 8k and 3k. And that gives me negative 5k. All right. How are we going to get 2k squared? Well, the only way you can get that, 2 is prime, so it's 2k times k. 2k times something gives me negative 8, or you could think negative 8 divided by 2k is what? That's negative 4, so that's what goes there. 3k over k is 3, so in reverse, 3 times k gives me 3k. Negative 4 times 3 is negative 12. So my two factors are k minus 4 and 2k plus 3. And that's this part of factoring mentally. Again, look to factor mentally if you have no coefficient in front of your square term, or if you have a difference of squares. Be able to recognize that very easily. Okay, now let's move on. We're going to move on to the next page. Here we have some geometry application problems. We've got the area of rectangles represented by this. Find the length and the width. Well, you've got a rectangle. Okay, you want the length and you want the width. Length times width is going to give me this area. Well, what have we been doing? We've been factoring, and two factors, one times the other, gives us this polynomial. So I would say it's a good idea just to factor this, and find that will be your length and your width. Okay, so again, we can do our box if you want to use the box. And we have 3x squared up here. Make it right as squared. And we have a -6 down here. And we need factors that will have to be -7 multiplied to be -18x squared. And we have the one's positive and one's negative, so I would say that would be -9x and 2x. Okay. Now, in essence, this is your rectangle that has this area. Okay, and that's what we've been doing. Now we're going to find the length and the width. The way to get 3x squared is 3x times x. 3 times -3 is going to give me -9x. X times 2 is going to give me 2x, and 2 times -3 is 6. So my two factors, the length and width of that rectangle, are x plus erase here. And I didn't mean to make that long mark there. Okay. So we're going to have write our two factors. We have x minus 3 and 3x plus 2. Again, my writing's bad. I've got to figure out how to get my Mobi to work again. All right, here, area of a square, they give you the area. What's the length of each side of the square? Okay, so this time we've got the same thing happening, but our dimensions are going to be the same because it's a square. And if they don't come out the same, we should know we've done something wrong. So we have 4x squared and 9. Okay, the only way for these dimensions to be the same is if this is 2x times 2x. Okay, the way to get 9 would be 3 times 3, and that's two factors. Now, if when we multiply these, we're going to notice that the way to get this would be 6x plus 6x. So the length and width are 2x plus 3. Each of them have that measure. Okay. On this one, you do it much like you did 10. You're given the rectangle. You're given a rectangular lot. So draw it. Okay, and I have 14x squared here. And -40. And I'm given one of the dimensions, so I'm going to put that up there, 7x plus 8. All right, so let's go back. 14 divided by 7x means this dimension has to be 2x. That's what's going to give me a area in this little box of 14x squared. 8 times 5, negative 5, will give me negative 40. Okay, that means this dimension must be 35x, negative 35x, when I multiply it. And this dimension, 8 times 2, must be 16x. And if I subtract that, I'll find that that is negative 19, so it checks out. So if the width is 7x plus 8, I look at this other dimension that I just discovered, and it is 2x plus 5. So that is the length of the rectangle. Okay, now I'm going to move this up a little bit if I can. Well, it doesn't look like it's going to let me move it up. So to find, it gives me the length and width, we have to find the area. So what are we going to do? We're going to multiply these two. You multiply length times width to get area. So we have 4x plus 3 times 5x minus 2. And we multiply that, and we have 4x times 5x is 20x squared. Okay, 20x squared. And then 4x times negative 2 is minus 8x. And plus 15x. And minus 6. Okay. And then I can combine these two, 8x and 15x. 8 or 15 minus 8 is going to be 7x. So I'm going to erase this since I can, and I'm out of room. And so instead of 15x, I'm going to put plus 7x plus 7x, and minus 6 is still there. And then that's the area of the rectangle. Okay. That's the end of this topic. Let me get on my